Hello, everyone, and welcome to another episode of OpenObservability Talks. I'm your host, Utan Horvitz, and here at OpenObservability Talks, we talk about anything DevOps, observability, and open source. So, as I always say, may the open source be with you. And for those joining the live stream on YouTube or Twitch, feel free to share questions and comments on the chat. Happy to take in some interesting questions to our fireside chat here. And with that, let's move on to today's episode. And today we'll talk about observability into mobile native apps. Observability into mobile native apps presents unique challenges from capturing real user interactions to dealing with network constraints, battery efficiency, and whatnot. Definitely things that are a bit strange to back and forth, such as myself. So keen to hear more about that. And today's guest is Hanson Ho. He's an Android architect at Embrace and an approver on the OpenTelemetry Android SDK. So he's a real expert on this topic. He brings a wealth of experience from Twitter, Salesforce, SAP, and more. So I've got the right person for to tell you all about this. And hey, Hanson, great to have you here.
Hey, Dosen, how's it going?
Great. Where are you joining us from?
Vancouver, Canada.
Oh, cool. So, tell us, it's funny because I said that I come from, server-side development background for many years, and the mobile environment is so much different, especially for folks like me that we know on the first server side in a very fundamental way, which impacts the way that we design and develop software, as well as, of course, operate and monitor it. That's the main focus here on open observability. So I'm curious if when you talk to backend folks such as myself, can you share the unique characteristics of the mobile environment?
Well, mobile really is about running these programs on these shared multi-tenant devices that are very constrained in terms of hardware, running different versions of software, having different capabilities of hardware, and you have a user at the end controlling how it's executed. So it's basically chaos. Telemetry is great if we can get it. Sometimes you don't get it, and sometimes you record too much telemetry. That data actually impacts the performance of the app itself. It uses too much bandwidth, CPU, memory, all that stuff. So you have to be very careful in how you track behavior and telemetry on mobile devices. And at the end of the day, you're not monitoring a cluster. You're monitoring millions of tiny devices. You have one person who may not be using it very well, and they are affected, and you have to kind of know this. So P99, well, for 100 million people, P99 is a million people. So you have to know what you're looking at, and you have to know that there's a user behind every interaction, and it's not just a number about how well performing a cluster is. So
Yeah, and in addition to everything you said, because you come from the Android background, I think Android adds even more challenges, especially if you compare it to iOS, very controlled, the span of devices, their age, how old they are, and so on. Like Android is much more diverse. OEMs, models, ages, right?
manufacturer, I mean, only Apple makes iPhones, as far as I'm aware of. Android phones can not only be phones, they could be embedded devices, they can work in cars, they could be kiosks, go to McDonald's, what powers that? Well, sometimes it's an Android device in the background. You're talking about OS versions. We support up until Android 5, which was released 2015, something like that. So this is 10 years. Hardware capability so the amount of errors that can happen is not really predictable. So you think about the test matrix of software, hardware, runtime environment. You can't really know everything before you actually release. So, which is doubly more important why we have observability and production metrics. So you know what's actually happening, in the real world. You can't just look at your machine and say, hey, how's that going? No. If you don't tell yourself, no one's going to tell you, and people could be crashing and just experiencing terrible performance, and you just wouldn't know it.
Unless suddenly you get the angry users cursing you on, I don't know, whatever social media is popular these days. And that's not a good way to have an indication of an error in your system.
No, if your monitoring is a spike of 1-star reviews in the App Store, that's that's a pretty delayed access, and for every one review, there's thousands of dissatisfied users. So it really is the tip of the iceberg, and you really should know. Look at the surface, look beyond the surface, and see how your app is running. So that's why it's doubly important that we have all this.
Yeah, and it's interesting because this, of course, impacts monitoring, observability, telemetry collection, and from what I gather, because of all this chaos that you mentioned, it actually should be very, very crucial to mobile development. But when I think about the way that I perceive observability in mobile, it actually feels to me at least less evolved than in the backend side. Like in the backend side, these days I can say, and I go all around the world and I talk to many audiences, the conversation has evolved and you see much more understanding. And mobile, I know that for many years we talked like more about crash reporting, right, and things like that, debugging approach, and errors. I'm wondering, because of everything you described, how much do you see the awareness today, and how wrong am I about the typical front end developer and mobile developer and Android developer in particular with regards to monitoring and observability?
Well, it really is two separate groups here. So you have folks who are working in big tech, who have the infrastructure, in the back end to take in telemetry, and big enough teams to actually build up clients and also the instrumentation. Then you have everybody else who just wants to get by, who wants to ship their app and make sure things work. And what they do typically is have crash logging. So when something goes bad, i.e. a crash, they know about it and they can fix it. Oh, we released a new app version. There's a spike in this crash. Oh, it's an NPE somewhere. Gotta go fix that. Um, but it's not easy to get basic telemetry because you don't necessarily have all the tools in the back end to actually take that all in. So imagine if you're just a mobile game developer, you have an app that mostly runs on the client side, makes some basic server calls to the API to get some data. Well, how do you get telemetry? Well, first I'm gonna have to build the SDK and collect it and then send it. And well, somewhere in the server has to take in the SDK data and then process that and aggregate it. And you have a dashboard to show it. And how is one mobile indie game developer gonna stand up all this in the back end? I mean, now with OpenTelemetry, I think there is at least a pathway where you could, have an open source solution to set things on your own, or you can use a vendor who, will give you all this information and, charge a fee for it. But at the end of the day, you're just worried about shipping your next feature. You're shipping your next version. You're fixing the crashes. So it's almost a luxury to be able to monitor performance. But it matters, which is why you have folks that are in this and have large teams. You have, the Slacks and the Facebooks and the Twitters of the world, where they understand how impactful client performance is and how knowing about it is the first step in fixing it. Imagine if you have all your backend observability to make sure that, if anything happens in the backend to generate a feed for your Twitter client, that if there's a 50 millisecond delay or some sort of consistency that takes a couple seconds to resolve itself. Imagine if your app just has a really slow network queue and the network request doesn't make it off device. Imagine if serialization takes a lot longer than you expect. Imagine if serialization crashes the app. So for the back end, yeah, 200, cool, requests succeed. The user sees not the app crash, but simply that nothing shows up on their page or on their app because the data somehow, some error got handled, but the user didn't know about it. So your crash logger didn't pick it up and your backend didn't know about it, but the user's pissed off. So how do
Yeah.
you actually know this? Well, you instrument and you have observability. And this is where we're getting to, where I think not only the large firms and big companies, those that know that matters and can support a mobile observability team or the equivalent, not only can they play in this sandbox and have all this tooling, others can as well. And OpenTelemetry and Embrace and anybody who's working on mobile observability is trying to make that happen. You used to have RUM, which is monitoring user interactions, so not really performance, but just like what buttons they clicked on. You have your network requests and you have your crashes, but it's not enough. You can't answer questions about your app unless you have observability, unless you have the ability to transform and slice and dice your data and see what cohort is experiencing what type of performance, and then leading to outcomes. So what if app startup is 50% slower? The number is increasing, but do I actually know what that means? In terms of revenue, in terms of DAU, in terms of retention, in terms of churn, all this cannot be answered unless you have observability into how the app works in production.
That's right. And I think that this first of all, it's very, very encouraging hearing that, and I know that you're obviously on the more advanced edge of the end of the spectrum in the mobile development, but hearing that you see more awareness to observability also in the mobile world is very encouraging, because again, for a long time I felt that sort of the backend side moved quicker in the evolution of observability, and in the front end it was still left as an afterthought, or something baggage that you need to someone else's problem, and not in an inherent capability that you need to have. And also I think what you touched upon is very interesting, because there is a direct line to the business impact, and I've been talking about that on the show in many episodes with charity majors and with others, and with founders of startups and so on. It was very interesting to see, and I'm also a product manager in past life, so I get this connection very intuitively. But I think the observability as a means to understand the vital signs of your business, and even the sort of so-called technical issues, how they translate to business bottom line. And you gave some very interesting examples here, and especially in mobile. They talk about I don't know, the new game you launched, or your shopping app or whatnot. This is direct impact. So I'm curious, what's your take? Like, what pains do you see that currently are having, beyond, again, just as you said, just crashes and these sorts of technical elements? What are fundamental capabilities that companies developing mobile apps need to care about, and currently are challenged with it?
Well, they need to understand how the performance of the app affects, the ultimate user choice to use your app. Because when things like crashes happen, it may seem very dramatic because, well, crash happened. I know what happened, so I care about it, so I fix it. But slowness is, first of all, hard to define, right? Because what is P50? I mean, it depends on who's using it. If your devices are faster, your P50 might be faster just because the population is faster. So your mean moves to the fast end. If your app is so bad for slow devices and you actually lose those users, your P50 might increase, or rather improve, because your slow users aren't using it. But how much of your total addressable market are you losing if you're basically saying, oh, I'm sorry, you have to have, a pretty fast phone in order to use our app. Hey, your metrics might look great, your P50 might look great, your P95 even might look great, but users are not using your app. So fundamentally, having this access to user data, you should be able to trace it back and get an idea of what it means for a user to suffer bad performance, not only in the short term, in the current session that they're working with, but does it affect how they use it in the future? Are you going to be more used to, are you going to be more likely to use an app that performs fast? Or are you going to use one that is janky, especially if you have choice? So if you're working for a bank or something like that, you're not going to change your bank because the mobile app is slow. But if you're ordering food delivery and there's one mobile app that is way faster than the other, you don't care who delivers the food ultimately. If the price is roughly the same, you want the one where the app experience is positive. You're not gonna, wait 10 seconds to submit your transaction and say, hey, cool. Oh, my credit card was declined. It takes you 10 seconds. So the ability on mobile to create that direct link is I think the opportunity. It's what, mobile developers, and not even mobile developers, even SREs should think about. How do I extend my usage, or my backend infrastructure, to tell more about what the user is doing? Well, you collect data from the client, from apps, especially if everything on your backend is open telemetry, and your front end, and your app is open telemetry. Maybe the collection methods are a little bit different. Maybe what you're modeling is different. The frequency of data submission might be different, but at least they are shaped the same. You could link them. Like, imagine how much power you get just by having, a span be sent representing a network request. Imagine all that data that's coming from the client side that could be used to enrich your backend traces that may be too difficult to parse out, if you have to like blow up your request's body in order to get data for observability. It may be too much overhead, but we could tell you exactly what it is. We could send it to you as part of the span, because we can break it down. What about network conditions, things that are invisible and erased by the time a request is sent? Oh yeah, it took me 10 seconds waiting in the queue for this request to be sent. This is why people were giving up after 2 seconds. It's because they're waiting 10 seconds already. It's not that people are impatient, it's that they've been waiting for a long time already. So the ability to enrich your backend data is what SREs should, if nothing else, look to it and say, hey, this is great. I want this. Now, I think politically it might be difficult to deal with, because SRE orgs may not be owned by the same, VP or director as your mobile team. So there is some, practical concerns in terms of prioritization and scheduling. But they're all one company. You roll up to the bottom line. There's one stock price. I don't care if you're working for the backend SRE team or you're a mobile developer. Your RSUs are dependent on the price go up. Your customers, your board of directors care about that. Everybody's aligned. You align incentives, and at the end of the day, the tools are there now for mobile to help in this.
Yeah, and I think there is a linkage between obviously the data from mobile to backend. Obviously, the organizational structure is not always doesn't always lend itself to closing this loop to get really end-to-end observability. But what you're saying about, again, using traces and trace data spans as being, for those who don't know, our listeners, these are like the steps in the trace, or the hops in the trace. This is, again, I'm really happy to hear that this is becoming very more common in mobile apps to consume. And by the way, I always understood, to be fair, like, it sounds like I criticize the mobile developer. I think there were very relevant and very valid reasons to let's say, be apprehensive from adopting the full observability, or at least the telemetry shipping, because of the very constrained environment. Like, even by the way, even in the backend, there are lots of people who say that the performance of a certain OTel agent or other instrumentation client or whatnot is too consuming for server side, let alone if you run that now on very constrained mobile device, and you take out of the anyway very constrained and sensitive environment some CPU cycles, some storage, some buffer sizes, to now do the telemetry collection side. So you need to be, and I assume so you as an SDK developer, be very sensitive in how much data you can collect in real time, how you do that in terms of is it sent in real time or in a backend thread, or do you send it, is it something that can be aggregated and sent a bit later? Like, there are lots of sensitivities because of the constrained device and the network. Obviously, again, I know that we're now talking 5G and 6G, whatnot, but still, compared to being connected on the back end inside the data center, it's still limited. they're valid concerns, right? You need to balance everything, all the wish list that you just described, with what can be done effectively on the device.
Yeah, because not only is there practical concerns about, so, on the server side, you could do tail sampling in order to like, record everything and only send what you need, which helps a lot with the data volume at the end of the day when you can drop like 90% of data or even more. On mobile, the act of recording that and storing that and caching that has an overhead that even if you don't send it to the backend, even if the backend drops it, you're incurring the penalty. The penalty isn't generally in the submission and the transmission; it's in the collection and persisting, and in a durable way. And when you talk about 5G, 5G works slowly in a parking lot underground, 5 floors deep, in elevator shafts, and also a lot of people are using really slow devices as well, especially on Android. Even like people say, oh yeah, maybe emerging markets, that's where this is relevant. No, in North America, in Europe, in places where adoption of new devices are high, you still have older devices being sold at convenience stores. You still have hand-me-downs that you give to your grandparents or your parents, that are fine 5 years ago, but may not be anymore. They're running Android 5 and 6 and 7 that really shouldn't be run because security updates have long since lapsed. But they're still in use. We see the numbers. I mean, Google recently dropped Android Vitals monitoring for Android, I want to say 9 and below. Android 10 was 7 years ago, 6 years ago. So even like the minimally supported versions that Google has in their dashboards, is still quite old. Uh, so the idea of technology improving and making things better, well, it is to a degree, but on mobile you're always going to have that long tail of overhead, of data loss. So all the assumptions you could have in the back end, the mobile, you kind of just have to throw them away. um, Even more than ever, even more than back end, you need to know what happens because you can't control the environment, and you can't even test truly the overhead. You can have benchmarks that say, hey, I have a certain device, I'm going to run it in a benchmark condition. Well, they're not listening to music on the subway while you benchmarking. The runtime environment is different from your benchmark. You can have a good idea of how much overhead you're taking, but the disk could be full. There could be GC happening because lots of other apps are in the background. Only production data tells you the truth about how your app. You could do a lot with benchmarking. I definitely think you should benchmark, but that's not the end all be all.
Yeah, yeah. And I should say, I mentioned that at the beginning, you've been doing it for many years. You did that at Twitter already a decade ago. So maybe can you tell us about your like end user experience implementing monitoring in mobile apps at Twitter scale? And you mentioned before, you touched about the fact that like when you go to the hyperscalers in the larger scale, then you have a clearer discipline where you have dedicated teams and you can do much more methodological approach to observability. So maybe learning some of this experience that you say now the smaller companies are also starting to adopt. So interesting to hear about that.
So yeah, 10 years ago, I started at Twitter, picked up my first Android phone, and says, "What is this mobile phone business?" I was working on web stuff before, enterprise web stuff, which is not as fun and it's not cutting edge as mobile. So learning about how users use the app, how we on the client side can help improve that, and also the network, how we could actually manage that, taught me a great deal about empathy, about not everybody's going to have a good condition when using your app. So for Twitter, I was hired onto a team that tried to improve performance for Android, especially targeted towards emerging markets for growth, because we want to make sure that the app works well for folks who don't have the latest phones and who have limited bandwidth, 2G, or they have very strict data usage requirements. And through that, I learned how important it is to measure, because there were things that we tried to do, like prefetching. It's like, oh yeah, we're gonna wait till it's connected to Wi-Fi and then save the images and save the tweets and show it up. And you're like, oh, that's going to be great because we're not going to use any data. And there's like tweets when you wake up in the morning. And it turns out not so much because people want the latest information. So all your expectations of how users, people react to performance, what matters to them, at the end of the day, you have to know their final decision, whether they use your app or they don't use your app. So experimentation is extremely important to Twitter, and to build a framework to allow data coming from the client to basically be part of that experimentation. We can change the performance of a particular workflow and do an A/B test on it. Basically, have two buckets that are effectively identical, except for one has a treatment, one doesn't have a treatment, and then it'll tell us how long, what the impact of that is, DAU, revenue, time in app, and slowly that became my job. When not only did we improve performance, we're able to basically justify performance work within the Android team or in the iOS team. We're able to basically say, yeah, okay, cool. You want to ship this feature? You think you'll add 100,000 DAU? Projection. We could literally show you in an A/B test that runs, for 9 months, the difference in DAU, in churn, in revenue that accumulation brings you. Because when you lose a user, you don't lose that user for just that session. You lose them forever. It's AAR, it's ARR, it's recurring. So just keeping the users from churning, the impact is multiplicative. Multiplicative? Yeah. So if your app can benefit from recurrent use, if your app could benefit from opening up the user base to lower end devices, this is when you need to know at the margins how your app is performing, and not just like, oh, it took 2 seconds to do this. No. Did they buy? Did they continue to use the app? How long did they use the app for? Performance doesn't matter at all if it doesn't affect how your users use your app. So it's not people track crashes. Oh, crash rate, I gotta make sure my crash free rate is 99.9%. Well, does the crash matter? If the crash happens in the background as you are basically backgrounding the app, you're not even using it, in half a second later. Who cares if it crashes? So the impact of that crash is what you want to remedy, not the crash itself. So observability allows to give us that. We monitor not only what happens, but the implication of what happens. Oh, Dotan, I think you're on mute.
Yeah, sorry about that. I think Twitter is a great example. I had a few from Twitter also on the show in the past, but it's very interesting because of this always the constant connection to the impact on the user. So I think this is something that is sounds like it's very ingrained in the culture, and also something that you said that comes obviously with a high scale is the fact that you can really test things out in production. You can really understand the impact by trying it out on a very slice, like canary testing, if you will, and then see the impact on that slice and really prove it. Because as you said, our assumption of our users are not valid. Yeah, sorry about that. So I think it's very interesting to see. Of course, you need the scale in order to execute something like that. And I think before we go into OpenTelemetry, we mentioned a few things. Can you tell us like what's a way they've been doing observability in the past decade or so? Obviously, not just Twitter or so, that also a lot of the stack is in-house. But what were the best practices the day before we introduced OpenTelemetry, and then we'll show maybe a bit about what's the major benefits that OpenTelemetry approach brings with it. But give us the way that things used to run in the before that.
Well, things used to run by guessing. Basically, you release a version of the app and you see your core metrics move, and you say, well, maybe this was caused by us having a new splash screen, or we have a new feature, or so on mobile, you're basically guessing your impact. So you can't even attribute impact. So experimentation is probably something that's out of the hands for a lot of people, just because, as you said, you need the scale in order to actually do a slice and do a A/B testing and all that stuff. But you could do correlational analysis, certainly with cohorts. Um, now you may not have a control, to compare it against, but if you change for a cohort, um, a certain property, and you see a change, coincide, not with a release, but like with just turning on the feature flag or something like that, then that doesn't prove anything, but it gives you a, an avenue to investigate. So I would say, like, if you can't experiment A/B tests, at least do it, adding some telemetry, and start slicing and dicing and say, hey, well, what if, like, do churn rates differ for users that have a bad performance experience, compared to the ones who have an acceptable performance experience? So getting the data, getting lots of dimensions for the telemetry. So it's very important is to capture context, runtime context, device context, user context, so that you could put it in the back end that can allow you to slice and dice, so you can play with the data and let the data tell you what the app and how the app is performing. So
Yeah.
so start with something simple. One trace, lots of context. One trace. What's the one workflow you care about? Make one trace. No child spans. One trace. One trace.
Yeah.
Well, one span, I should
Although
say.
context comes with a price on the other side, again, going back to the trade-off, and the cardinality usually gets exponential with its impact, and what incurs on storage and caching, and even networking in case of something like mobile. But as you said, the context is essential. Otherwise, it's guesswork of trying to compare. Okay, is this peak and this peak? Do they say something is it causation or just correlation, and so on, and all these discussions? So I think it's really guesswork. And also, talking about how things used to work or still work in mobile, there are like table stakes observability provided by Google and things like that, right?
Google provides crash monitoring and vitals tracking. So you can tell what the P50 and P75 of your entire population is for app startup, or whatever it is. But you can't slice and dice. So it's I would call it monitoring, which is honestly way better than they had 10 years ago or 5 years ago even. But it's not observability, because you can't explain why changes happen. You can't compare cohorts. Some you can. You can look at maybe, like, OS versions and things like that. So things that Google readily has access to. Um, and but you also can't track arbitrary workflows. You're going to be able to get startup time, and a couple other things, some jank stats. So it's better than nothing, but it's very limited still.
Gotcha. No, but it's good. Like, I know that they've tried at least to, as you said, like what they have now and what they had 5 or 7 years ago. So at least they give some sort of table stake. But as you said, it's not observability; it's monitoring. And we talked a lot. We hinted about what we bring to the table with OTel, with OpenTelemetry. So really, at OTel, and me being on that side, also with you and many others, obviously, we've seen, and I have to be honest, as a project, we started with the server side. So a lot of the design and focus has been server side focused. But then we also expanded, and actually we are still expanding. It's a process ongoing into the client side. This is actually what the client side telemetry SIG, special interest group, is tasked with, assisted by various specialized working groups. So again, for our audience to just get to know, so things like you mentioned for RAM, like real user monitoring, the need to monitor client-side interactions. We talked a lot about native mobile apps, but of course also web apps and others. All of that falls under this realm of client side, and some people ask me, okay, but you could have done that. You have the JavaScript instrumentation, things like that. And it's true on the technical side of you could have run the SDK for JavaScript, for example, wherever it's relevant. But people need to understand that OTel is not just the SDKs, but also the semantic conventions and the specification and the need to model these entities like session ID, page view, other elements that are native to client side. They don't exist in server side altogether. So even if you have an SDK, but you don't have the language to describe these very basic tenets of client side, we lose a lot of the power of OpenTelemetry. This is why it's important for me to emphasize, because many people don't see the specification and the semantic conventions. It's the more abstract paths or parts of the project, but these are essential. It's first and foremost for me an open specification, even before being an open source tool. So being able to ask questions like, counting the number of new users versus number of returning users, or visualizing the navigation through your UI, or identifying pages that generate errors, all these questions that are very basic to client side, we needed to allow users to articulate them, to report them, and then, as of course, comes the SDKs that then provide the instrumentation per language. So this is just a background for our audience, and all of that, by the way, is today an established piece of OpenTelemetry. But you're a member of that SIG, so I'm actually curious if you can give your take as a front-end developer. What was that for you, and what is that for you? The mission statement of the SIG.
So I think the mission statement, to my mind at least, is to effectively bring to light client-specific concerns to the other folks who other maintainers of the spec and things like that. But on the client side, even as you said, mobile web is very different than a native mobile in terms of execution, in terms of stability, things like that. But OpenTelemetry provides us with an alphabet, and I think the semantic conventions puts those letters into words and gives meaning. So what is a crash? Well, a crash is potentially a log record with some set of attributes that are predefined, so that when you log it on the client side, the backend can process and know exactly what they're dealing with. Without that schema, without that map, all you have is a bunch of keys, and you have to know, oh, what am I looking at? Well, how do I parse this? What kind of format is this? What kind of encoding? Without semantic conventions, OpenTelemetry would not be something that a community can share and basically do its stated purpose, which is effectively an open source way of modeling telemetry that is vendor agnostic and all that. So the SIG itself is, I think, a good gateway into kind of surfacing some of these problems, but at the end of the day, you're still going to have to work through them yourself. And it's funny when you say, you can have the JavaScript SDK and it works. And I mean, it does, but if you talk to the JavaScript folks who work on the web, who have to use an SDK designed for Node in the backend, there are some challenges. Similarly, for Android, we currently use a Java SDK. And as you said, it was built for a backend use case. It was built for execution model where request comes in, goes on a thread, spawns a bunch of threads, at the end they produce a response, and you're modeling the execution of your app deterministically. On mobile, what is that? Is that the main thread? Is that the background thread if you kick off a job? Well, what if you go through coroutines that goes through several threads? What if there's a button click starts a workflow, which is on the UI thread, and a bunch of stuff happens in the background and sends a request, and several threads are happening. So while support ultimately means, does the SDK run? The other end of the spectrum is, does it run well? Does it meet the expectations of the developers using it? Is it idiomatic? And does it cause overhead or handle cases that are expected? Like, what if crash happens in the middle of doing a span? Well, OpenTelemetry, I guess if you could find out when you crash and you can stop the span and record its fail, that's great. But processes terminate without letting us know. Then what
Yeah.
happens? Well, it would be great if I can send part of it through the wire, and then But oh no, I'm sorry. OpenTelemetry is span is a span is a span, and it's the same one. Partial. What is this partial? Well, model is multiple spans. Okay, then we'll link it together with span links, so the challenge right now is not getting it to function. I think on iOS and on with the Swift and on Java and also on JavaScript, it functions. Whether it works well, whether somebody who's just picking this up will want to use the API and the SDK for mobile or client, observability. Well, frankly, if you talk to a mobile developer and ask them what a span is or a trace is, not not everyone can tell you. So we're even at a place where there's some language expectations that are different. Like that when you mentioned previously the Android SDK, well, it's more like an agent that uses the Java SDK and Java API, and also hardwires a bunch of instrumentation included in the agent, and also some custom open source implementation. But we can't do bytecode instrumentation the way the backend does at runtime. So we have to do certain things. And so again, I
Yeah.
think the SIGs are there to make this experience better, is to make a more pleasant and idiomatic experience for client developers. And we're still at the very beginning. So not to like say, I'll just say negative things, because like having a spec, having a specification that we all agree on, that is actually quite open, that you could model so much on it, is the start of something. It is step one, and semantic conventions is step two, and then step three, tooling, especially more native mobile and web tailored tooling. When we're talking about metrics, for instance, it's really hard to do OTelemetrics on devices when you have device IDs and session IDs that are high cardinality. How do you create a time series? Your backend is going to blow up. So I guess we just don't. But what if we do? What can we do to make things a little bit better? Context changes all the time. Do you always put it as an attribute? Well, what if there's a thrashing of network and the connection changes 100 times a second? Is that 100 attributes, 100 span events? So these are unique problems that technically the spec can model. But is it the most optimal? Is the tooling the most optimal? I think that's where step three and step four and et cetera come from, is the fine tuning. And we need as many people with as many perspectives as we want, because my focus is native mobile apps, and really it's a very subsection of mobile apps use a device to do it. I'm not working on cars. I'm not working on Android Auto. I'm not working on IoT. I'm not working on a lot of these devices that they have execution life cycles that are different than what I'm expecting. I expect people to pull up the phone, use it for a few minutes, close it, and have a discrete life cycle. Well, kiosk apps at McDonald's doesn't have that. It's just there in the morning, and well, do we keep data at the end until the session ends? Like, what is a session? All that stuff. But
Yeah, and then it's interesting because we started by saying that OpenTelemetry has now the client-side telemetry SIG, but this is so massive. Maybe server-side folks look at all the client-side as one bar, but it's so different. Even within the native mobile, you talked about such a diversity, and then you take in the web apps, and you take in like each one, and as you said, the IoT life cycle of an app is so different than the like personal consumption as a phone. So, and this is by obviously, for those who don't know, then there's the working groups that specialize, and you're on the OTel Android SDK working group, where you're also an approver there. So way to go on this one. And so maybe can you tell us about the working group specifically, both for people to understand what a working group is in this regard, and also specifically what's your focus areas, which platforms are supported, and so on, just so people who are on Android, more Android specific, maybe can understand where the focus areas these days go.
So where the interest goes, an interest group lies, basically. So right now, there is a web-specific interest group. There is a Swift working group, and there's also the Android one. The Android one obviously is agent slash instrumentation that uses Java SDK. So for us, really the focus is stabilizing the current offering, and getting it to 1.0, and also discuss problems that are in general that folks have on the client, things like sessions, things that we have to work around, and iOS and Android, we're different, but we're also very similar. We're certainly a lot more similar than we are with web, but we're also very similar with web, compared to, say, your backend distributed system. Semantic conventions for us is even more important because there is a shared language between mobile apps, native mobile apps at least, like with terms of crashes or frame drops or page load. These are the regardless of platform. These are primitives that are a level higher than a span, a level higher than a log, but they should be the same regardless if it's coming from an iOS device or a Android device. Maybe it's maybe the difference is between apps are so few, relatively speaking, compared to the backend. So you talk about diversity of backend applications. There's no way to, like, what do? You run some compute and calculate some things. But I'm sure each domain, like databases or AI, they have their own semantic convention working group and things like that. But for client, it's like the platform level. So what we really ultimately should be as a client group is stabilize the semantic conventions, figure out semantic conventions, figure out common client interests, like session management, like remote configuration, things that only the client cares about, or rather a device that is, when I say client, I'm not being specific enough, a device that is running outside of your data center, that you have no control over. When that is reporting data, there's a bunch of concerns. When your process could terminate at any time, you got to make sure the telemetry that you record is sent back eventually, and is durable. So the working groups are there, and anybody can join. The schedules are posted, in the OpenTelemetry various pages.
And on the
Embrace.
CNCF Slack, for those who are on the Slack, by the way, it's open for everyone. You don't need to pay. You don't need to be a member company. And there's the OTel client-side telemetry, like the big SIG, and obviously the working groups and everywhere, like, have designated chat.
And even before it gets to a SIG level, because SIG level really you require a lot of work, code, and interest. But there are platforms like React Native, like Flutter, like Kotlin multi-platform, other things that there are people working in those areas, like Embrace, where we have a React Native SDK, but there isn't there isn't so many people that were like, oh yeah, create a SIG for it. But there is interest, and if there's an interest, you could work together. You don't have to have a SIG. You can just set up a Zoom between a handful of people and just talk. And when the technology is at a point where it deserves its own kind of working group that is officially everywhere, then it'll come. But right now it's just people getting their hands dirty.
By the way,
And kind of
you mentioned React Native. I don't know. Is there an OTel initiative under React Native, or?
Embrace. So Embrace has a React Native SDK that uses our iOS and Android SDKs under the hood to do effectively React Native application telemetry and observability. So for those who are not familiar with React Native is basically you write in JavaScript and it generates. Generates a harsh word. It what you write JavaScript and you get native mobile apps, iOS and Android. Stuff happens in the middle that I I don't want to say the wrong thing and offend people.
And that's
Uh,
supported in OTel? Is there a working group working? Because I wasn't aware of that. So, and you mentioned before, so there is an active working group focused on React Native?
no.
Okay.
So the folks at Embrace go to the JavaScript working group and or the web working group and the client working group. But again, it hasn't raised to a position where there is a React Native OpenTelemetry SDK. So one day there may be, but right now there isn't. But it doesn't mean we can't work. It doesn't mean they can't help with semantic conventions.
No, it's
So
interesting to show how young it is. People maybe don't understand that it's really, really at the very beginning. Obviously, it's a call for everyone to take part and to impact, but just to understand it, there's so much still to be covered on this realm that is not even touched upon by the official working groups.
yeah, and these are just the ones I know about. I'm sure there are a bunch of people on client working on observability. They may not be open telemetry, but there's people who want to know what happens in production, and where that happens, OTel can potentially play a role.
Nice. You mentioned your company Embrace, who does very interesting things. Some of them in the open source with regards to observability and with embracing OpenTelemetry. And also, I found it very interesting the journey that you've made in adopting OpenTelemetry. Really, you had your own proprietary means, and then you migrated to OTel compatible. So I'm curious if you can share a bit about, maybe you can say a word about obviously what Embrace does. You mentioned a bit about that, and also this migration process. And I'm curious also if there are any tips for others that are planning to undergo such a migration that you can share with the broader community.
So Embrace started off as a company that is a rum crash logging product. I think we have some nice special sauce in terms of ANRs and things like that. But ultimately, we log data, client telemetry, send it back to our servers, and we give you some dashboards so you can monitor and do stuff with it. We realized that there's a ceiling for that type of siloed data that lives on its own, used only by mobile teams to monitor their crashes. OpenTelemetry gives us an opportunity to basically link that data with backend telemetry, so that folks who are interested in client information has a means of using it beyond, looking at a dashboard of crashes or a dashboard of ANRs. They can say, hey, this situation you're struggling with in the back end with latency with this particular region. Well, we have some extra data for you, and we realize how powerful having a unified framework and system is. So you don't live in silos. You could actually have all your data linked up in a way that they help reinforce and inform each other. Your failure could happen on the client. It could also happen in the server. There could be things happening in the server that affects how the client processes it because, I don't know, they use a different encoding in the response, so it crashes. And we found that out by having some backend, telemetry linked up to it. So we made that transformation, and we think it's vital because we went from monitoring, we went from making a better mobile rum crash logging product to effectively be the open telemetry agents living on mobile phones. So we have our SDK that we kind of rewrote, and then we use a Java SDK in the back. We're not in the back, but on the app. We're looking into doing a Kotlin native API and a Kotlin SDK, so we can support KMP and other things like that. On the horizon. But what it actually means is that we're an end user of OpenTelemetry, but we are also a producer of OpenTelemetry because we have semantic conventions and we use semantic conventions. We have our own kind of schemas that hopefully will eventually become semantic conventions. So we live in this kind of weird space where we support the OTel API. We implement the OTel API for tracing, but we also expose the Embrace API for mobile developers who are used to using, our API or an API where they can say add breadcrumb. Well, yeah, it's a log or it's a span event or whatever, but they don't care. They just want to see it on their dashboard. So we're hoping to kind of be the bridge for our customers into the OTel world, because a lot of our customers actually have folks who are using OTel in the backend. But previously, because of the silos, SREs don't talk to mobile teams. They don't know that. But now they're all logging effectively the same, um, in the same framework, in the same format. So they can start. The data can start talking. So if the data can start talking, maybe they can start talking. And it's important for us to have an open standard, to be vendor agnostic, even though we're a vendor. It's because we believe in the premise of having an open system, have an open API that you provide different SDKs and implementations for that are tailored to different environments. So having one API and one implementation is great. But what if we have one API and multiple SDK implementations that have different opinions, that is optimized for different workflows? And at Embrace, we want to be one of those specialized implementations, while at the same time working with everybody to stabilize the semantic conventions and stabilize the API with a mobile point of view. So I would love to see other SDKs come up. This is the Kotlin, the Android Auto SDK that implements the OTel API, that is designed to run in cars because cars are different, or what have you. So, the fact that I work on the OpenTelemetry Android project and the working group, and that Embrace, our SDK, doesn't actually use that code is almost a proof of concept of the separation between API and implementation. Because I think for a healthy ecosystem, you can't have just one SDK implementation for an API. Otherwise, why have that separation? The idea is that you have different levels of openness, from the spec to the API to the language specific API to the SDK. And where we want to insert ourselves is well, in the ecosystem, really.
No,
Um,
and if you want to say it, people tend to take the vanilla SDKs, and it's fine, by the way. And it's a lot of emphasis has been put in making them production ready and everything, but still, the architecture and the design is such that we agree upon the APIs and the architecture, but then the SDKs can take a lot of different shapes beyond just the vanilla out of the box supported by the community, so that it can be specialized as long as it speaks the same language, the same APIs, the same data model and semantic conventions and so on. It's definitely, this is the room where vendors can then innovate on the implementation that is more optimized, more performant, and so on. So I definitely see that as the manifestation of the manifesto of OpenTelemetry. I do want to go back. We have just a couple of minutes, if you can say briefly at least about your experience, or at least the tips. If you can share like the main 1-2 tips about migrating a company that has already an established proprietary or vendor based and then moving in OTel, what are the main tips that you can give our audience?
Understand what you are instrumenting. So the workflow, um, especially on the client side and on mobile, isn't just about the execution. It's not just about how do we model the different threads and how they come back together. It's really from a user's perspective. So understand where it starts and where it ends, and know that even though the numbers may change in terms of the milliseconds or things like that, maybe it shifts a little bit. Understand what you as an app care about, in terms of modeling a workflow, and then you just change the code. Instead of creating a whatever, a proprietary version of a span, where it starts and where it ends, you do it. And also know that on mobile, when you log something twice, you're absorbing twice the costs. So when you do experimentation and look at overhead, don't forget that in the OpenTelemetry version of your app where you're measuring overhead, you're also doing your other telemetry recording, your proprietary. So make sure you factor that out in a way, or include it in your analysis, because these things aren't free. So when you do the migration, make sure that the impact that OpenTelemetry or whatever SDK you put in has the same or similar overhead as what you used to. Otherwise, it becomes a bit of a apples to oranges comparison when you're trying to compare the two. So always measure. I guess use observability to for your migration of your observability
Yeah,
is my take.
meta observability for the observability migration.
Yeah, don't focus on
That's
the
the
small
perfect tip.
numbers.
Yeah, yeah. So we're getting to the end of the episode. So I do want to share with the audience where they can follow up on you. So first thing that we already mentioned is that I will also be at KubeCon London, KubeCon Europe, that is this year taking place actually next month in London. So do feel free to reach out to Hansen or to me. By the way, we'll both apparently I just figured out just before the episode that we're both going to be on the observatory, which is like an hotel booth that you can find and meet different SIGs. So I will be there on behalf of the CI/CD SIG and Hans on behalf of the client side and the Android. So this is a great place if you're into OpenTelemetry. Check out the schedule, the agenda for different SIGs and different maintainers that and SIG leads and so on that you can meet. So that's one place. Apart from that, where else can people follow you, Hansen, and the work that you've been describing?
So I skeet on Blue Sky. Uh, the day of evil.wtf. I have my website hansen.wtf. You can find me there. Search me for LinkedIn. My name is pretty idiosyncratic, so if you put a little effort into search engine, you'll be able to find me. I'll also be speaking at SRECon next week, talking about mobile observability and how that affects things. And you can find me around LinkedIn. Yeah, KubeCon, I'll be walking around. In Observability Day, I'll be around, and I'm always, well, I try as much as I can to attend the SIGs every week, Android. And yeah, I'm on Slack there, so find me there.
Yeah, CNCF Slack again, open for everyone to join, and you can find all the maintainers there and the different SIG calls, working groups, and so on. Highly recommended. Thank you so much, Hansen, for joining me on this episode.
Thanks, Hotels. This is really fun.
And of course, thanks to all our listeners for joining us on this episode. As always, all the episodes you can find them on your favorite podcast app or on YouTube. And if you are now listening to it there, then do know that we stream the episodes live on YouTube and Twitch. So follow us on Twitter, X at OpenObserve, or we're also on Blue Sky and or on LinkedIn. You can find all the live stream times and chime in on the discussions there. I'm Dotan Horvitz. Thank you very much for listening. See you on next month's episode. And until then, may the open source be with you.